Hello and welcome. This video is an overview of the Weldon V-MUX 6-step troubleshooting guide. The 6-step troubleshooting guide helps with basic V-MUX troubleshooting. Visit our website at www.akronbrass.com to download the PDF document. Click on the Vehicle Electronics tab for Weldon and Class 1 links. Click the link for firmware and diagnostic software under the Weldon logo. Scroll down to the Manuals section to find the 6-step guide and other helpful documents. You should also download and review the Troubleshooting Essentials document. It covers some extra details that are not mentioned in the 6-step guide. Here are the 6 steps. 1. Understand the vehicle. 2. Check inputs. 3. Check outputs. 4. Verify communication. 5. Divide the vehicle. And 6. Ask for help. This document is not always followed step by step. In a vehicle with no communication, there is no need to check inputs and outputs. You would go right to step 4. Step 1. Understand the vehicle. The key to fixing a problem is understanding how it is supposed to work. Schematics are helpful when they are available. The I/O and relationship reports are generated by the vehicle builder. They show wire designators, input and output locations, input commands, output logic, and load shed information. Contact the vehicle builder to get I/O and relationship reports, schematics, or any other information that will help resolve the problems. They will know how the nodes are programmed and where components are located. Here is a node input relationship report. It represents node 1, a Hercules node. The node location is shown in the upper right corner. The first 2 columns are channel number and the connector pin number. The OEM wire column shows wiring information, in this case, wire number, color, and gauge. The command column shows the V-MUX command that is sent when that input gets activated. The on-state column shows if the input needs ground, battery plus, or either. The type column shows how the input is supposed to work. Latching means it's on when the input signal is present. Momentary causes a changed message state with each pulse signal. Hit a switch once to turn on, and again to turn it off. Normally open means on with the signal present, and normally closed means it's on when the signal is not present. The comments column is used for helpful information. Here is a node outputs relationship report. It is a node 1 Hercules node, with node location shown in the upper right corner. Like the input page, the first 3 columns are channel number, connector number, and OEM wire. The name column shows output names as determined by the builder. The priority shedding column shows if an output will shed, and at what voltage. The left scene lights shed at 11.7 volts, load shed level 3. The relationship column shows the command logic needed to enable the output. There are 4 main logic terms used: on, and, or, and not. On just means the command needs to be on. Or means that one command or another needs to be on. And means that one command and another must be on. Not means the command must be off. Relationship levels allow different functions for different conditions. Left high beam is on solid for regular high beam operation, but will flash for level 1 wig-wag. The gauge and rocker dimmer output uses relationship levels to adjust PWM percentage. Relationship levels function like an OR. It will be on with either one set of conditions or the other. Step 2. Check inputs. Toggle the input switch and look for the command using the V-MUX diagnostic software. If you see the command, then the input is working. If you do not see the command, further troubleshooting is required. Use a meter or test light to check for proper signal to the input pin. See the relationship report to determine if it's a ground or battery plus signal. Common problems include faulty switches, faulty wiring, bad connections, or possibly a bad diode, if it is an older truck. Earlier versions of the Hercules node did not have programmable inputs. They could be enabled with either a ground or battery signal. Builders would sometimes put a diode in line with the switch to make it ground only or battery only. Generally, a diode failure would be a broken lead, not a burned out diode. Step 3. Check outputs. If there is a device that is not working, locate the wire from the node to the device. Remove the output connector from the node, and apply battery voltage to the wire. Use a fused source, in case there is a short circuit. If the device turns on, you know the device and wiring is good. Next, you need to determine why the node is not supplying the voltage. Use a voltmeter to check output voltage. When the output is on, it should be at the battery source voltage. An output that is off with no load attached may have a floating voltage up to 9 volts, caused by internal fault detection circuitry. It may cause small LED lights to glow dimly. Some common output problems are bad device ground, blown light bulb, bad connection, or load shedding due to low voltage. An output might also have a diagnostics fault. Once a fault occurs, the output stays off until node power gets reset. If the output is not on, make sure that all commands required to turn it on are active. You can use V-MUX diagnostics to send the command messages. Use the relationship report to determine what command logic is needed. If you don't have the report, it's possible to get that information from the node, using diagnostics. To send a command in diagnostics, first make sure it is connected to the network. Select the command category in the left drop-down box, and then select the actual command in the right box. Select the on or off state, and click the send button. The command should appear in the lower window. You may need to do this for all commands that are included in the output logic. If the output turns on, you know the output is not blown, and you may need to do input troubleshooting to find out why the needed commands are not being enabled. If you determine that the output has all the commands it needs, and the output shows no diagnostic faults, then the output FET might be blown, and the node would need to be sent back to factory for repair. You can ask a node if it sees an on or off state for any given command. Click Special Functions, Command Query, select the node, then select the command group, in this case exterior lighting. We'll select the scene left command. Click Send, and Node 1 reports that the scene left command is off. If we enable the command and ask again, Node 1 reports that it is on. Click the Close button to exit. Step 4. Verify communication. Ping the nodes from diagnostics or a Vista display, and look for the replies from all the nodes. Ping replies should be very quick. Slow ping replies indicate a communication problem. Watch for system voltage and the sync signal, which happens every few seconds. These messages come from node number 1. A missing sync signal causes other nodes to produce a VM out of network message. If you can see these messages with diagnostics, then there is network communication, just not from node 1. Check the PC and BC counters. These should be at, or near 0. If these counters are incrementing quickly, there is a communication problem between the network and computer. A node collision is when a node tries to send a message, and another one sends a message at the same time. The message checksum value will be wrong, and the messages get sent again. Having collisions is normal in a V-MUX network. You can use diagnostics to see how many collisions a node has detected. Select and mount the node. Click the Monitor Node Collisions button. The node collision number should be at or near 0. If the number is high, then further troubleshooting is required. Step 5. Divide the network. If communication is lost, divide the network to identify which part of the network is causing the problem. If you remove a branch of the network and communication returns to the rest of the nodes, then you know the problem lies with that branch, and you can troubleshoot accordingly. Common communication problems are water intrusion and the Y-splitters, shorted or open communication wires, and pins not properly locked into connector housings. Backwards network wires could cause problems, but that would be unusual on a completed vehicle. That would be found and fixed at the factory. Check ground wires to all nodes. A node with a bad or missing ground can appear to be operating correctly, but can cause inconsistent communication throughout the network. Step 6. Ask for help. The OEM that built the vehicle is your primary resource for how that vehicle was designed and manufactured. The OEM should be your first phone call if something on the vehicle is not working, and you don't understand why. The V-MUX hardware and software are designed and manufactured by Weldon. If you have software or hardware questions, or there are truck issues that are not getting resolved, please contact Weldon. We want to help find solutions. This concludes this video lesson. To learn more about the Weldon V-MUX system, please proceed to the next lesson. You can contact Weldon at 800-989-2718 if there are any questions.